Okay, for the introduction, elements combine in fixed ratios to form compound. For example, consider the compound aluminum chloride, which is AlCl3. Each molecule of AlCl3 is composed of exactly one aluminum atom and 3 chlorine atoms. Now for the purpose. The main objective is to synthesize and determine the empirical formula of the product of a reaction of zinc metal with solid iodine, and to determine the formula of an unknown hydrate. In Part A, you are asked to determine the chemical formula of a compound that is composed of only zinc and iodine. And in Part B, you will determine the number of moles of a water hydrate along with the determination of the identity of anhydrous salt produced. Also, the formula of the unknown hydrate compound. The materials we used for this experiment are beakers of 50 and 100 milliliter, a hot plate, your unknown hydrate which is provided, zinc metal in a powdered form, iodine, 2.0 moles acetic acid, the crucible and its cover, Bunsen burner, iron ring and iron stand, and wire.
Alright, for the procedure of Part A, you weigh out your 50 or 100 milliliter beaker and record what you got. For us, we used a 100 milliliter beaker and got 48.95 grams. After that, we added approximately 0.6 grams of metallic zinc. We weighed the beaker and the zinc together and got a mass of 49.82 grams. We then subtracted 49.82 grams with the mass of the beaker and got 0.87 grams of zinc. We took a piece of weighing paper and weighed it and got 0.39 grams, and then weighed out 0.6 grams of solid iodine. With the weigh paper and the mass of the iodine, we got 1.15 grams. For the mass of the iodine, we got 0.76 grams. We added the solid iodine to our beaker containing the zinc, and next we added 5 milliliters of 0.2 molar acetic acid. We swirled the beaker occasionally while recording our observations. The reaction was complete when the solution is colorless. You can tell this by placing the beaker on something white and seeing if there is any color left. After the reaction, there will be excess zinc. Carefully decant the solution into a clean, dry 100 milliliter beaker labeled unreacted zinc iodide product. Save this until the end and make sure the remaining zinc remains in the beaker. Add about 3 milliliters of 0.2 molar acetic acid to the beaker with the solid zinc. Swirl a few times and decant most of the solution onto your product solution beaker, but leave the solid zinc in the original beaker. You have just washed the zinc. Do this 2 more times for a total of 3 washings, then wash the zinc with DI water. Discard the DI washings into the collection beaker. Now dry the remaining zinc, put the beaker with the moist zinc on a hot plate and gently heat until it appears dry. The weight of the 100 milliliter beaker ended up being 46.84 grams. Remove the beaker from the hot plate and allow it to cool. Weigh the beaker with the zinc. For the first weight of the beaker with the zinc, we got 49.59 grams. We heat it again on the hot plate for another 5 minutes. Remove it and let it cool down. Weigh the beaker with the zinc in it. To be done with this experiment, the mass of the zinc has to be with 0.01 grams of the first weight. For our second weight, we got 49.58 grams. If it is 0.01 grams away from the first weighing, repeat the heating and cooling and continue until the mass does not change more than 0.01 grams between heating. If the mass increases, stop and use the smallest mass recorded. This means that the zinc has started to react with the air. For the mass of our remaining zinc, we got 0.24 grams.
Go.
In Part B, we weighed a clean and dry crucible with a cover, and it came out to weigh 43.73 grams. After that, we added approximately 0.4 grams of our unknown hydrate, but we came out and added 1.05 grams. And our crucible then weighed 44.78 grams. And then we placed the crucible with the unknown on our Bunsen burner and put the crucible cover on it, leaving it slightly open so that there was no crackling, but the gas could escape. Listen for any crackling, and if you hear it, carefully remove the crucible from the heat and until the crackling stops. After 5 minutes, heat the crucible more vigorously. The crucible needs to be heated for a total of 20 minutes. We started at 10:24 a.m. and the end time was 10:44 a.m. When the crucible is cool enough at room temperature, pick it up comfortably with your hands, weigh it, and record the mass. At room temperature, our crucible weighed 44.45 grams. And then place the crucible back on the burner and heat it for another 5 minutes. And make sure the mass is closer than 0.01 grams of the previous mass. Our second weight after 5 minutes of heating was 44.46 grams. If it's not closer to 0.01 grams of the previous mass, repeat the heating, cooling, and weighing cycle. Do it until the mass is 0.01 grams of the previous mass. Heating the hydrate removes the waters of hydration, leaving the anhydrous salt in the crucible. The water present was 0.32 grams. The mass of the salt was 0.73 grams. Pour a small portion of 6 molar HCl into a small beaker. Light a Bunsen burner, take a metal spatula and clean it by dipping it into the HCl and then placing it into the flame, and wait a minute. Repeat until no color is seen when placed in the flame. Put some of the remaining unknown onto the metal spatula and place it inside the flame and wait a minute. If you see a red bright flame, you have strontium chloride. If you do not see a bright red flame, you do not have strontium chloride. And if you see a red flame, then you are finished with the experiment. We did not see a red bright flame. If you do not see a red flame, put a small portion of around 0.1 grams of your unknown into a test tube and add a few milliliters of DI water. Drop a strip of magnesium metal into the solution and wait about 5 minutes. If you see a dark substance collecting on the magnesium strip, you have zinc sulfate. If you do not see the dark substance accumulating on the magnesium strip, you have magnesium sulfate. We did have a black substance collect on the strip, and therefore we had zinc sulfate.
For part A of our calculations, we have to find the moles of iodine. So to do this, we need to take the mass of iodine weighed, which is 0.76 grams, and divide that by the molar mass of atomic iodine, which is 126.90 grams per mole. This turns out to be equal to 6.0 times 10 to the negative third moles of iodine. Then we had to find the moles of zinc. So first we would take the mass of the beaker with dry zinc, which is 49.59 grams, and subtract that with the mass of the empty beaker, which is 48.95 grams. Which gives us 0.64 grams of zinc remaining. Then we had to take the initial mass of the zinc, which was 0.87 grams, and subtract it with the amount of zinc remaining. Which is equal to 0.23 grams of zinc reacted. Then we had to divide our zinc reacted, which is 0.23 grams, and divide that by the molar mass of zinc, which is 65.38 grams per mole, which is equal to 3.5 times 10 to the negative third moles of zinc. For the empirical formula, you take the moles of iodine and divide it by the moles of zinc. Whenever you get this number, which is equal to 1.7, that tells you the amount of atoms you have in the iodine. So to write your empirical formula, you know that it's zinc, iodine 1.7. but you can't have a decimal for atoms for iodine, so you have to multiply until you get the normal whole number ratios for each number. We found out that if you multiply this by 3, it gives you Zn3 and I5, making them both whole numbers able to be used for our empirical formula. For part B of our calculations, we had to find the mass of water. So to do this, we had to take the mass of our hydrate, which was 1.05 grams, and subtract it with our mass of our anhydrous salt, which was 0.73 grams. Meaning that our water amount was 0.32 grams. Next, we had to find the mass of our anhydrous salt. We took the mass of the crucible with the salt after last heating, which was 44.46 grams. And we subtracted it with the mass of our crucible, which was 43.73 grams, which means that our salt weighed 0.73 grams. Next, we had to find the moles of water. So to do this, we took the mass of water, which we found out was 0.32 grams, and we divided it with the molar mass of water, which was 18.02 grams per mole, which means that our water was 1.8 times 10 to the negative 2 moles.